So, good morning, everyone. Our topic is all about the diastrophism. So, I am Lovely Rosie Berlado, and the topic that assigned in our group is all about the diastrophism, the meaning of the diastrophism, types of Earth movement, the theories of diastrophism, structural features of Earth movement, and types of faults. Diastrophism. So, diastrophism is the process of deformation of the Earth's crust, which involves folding and faulting. So, diastrophism can be considered part of geotectonic. So, the word is derived from the Greek word diastrop or diastrophy or distortion or dislocation.
As we know that the Earth has two types of motions, namely rotation and revolution. Rotation is the movement of the Earth on its axis. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. The axis of the Earth, which is an imaginary line, makes an angle of 66 and one-half degree with its orbital plane. Rotation and revolution are two motions of the Earth. When Earth spins or rotates around its axis, that movement of spinning is called rotation of Earth. And when Earth spins or revolves around the Sun, that movement is called revolution of Earth.
Now, let's proceed to theories of diastrophism. Theory of isolasticity, expansion theory, contraction theory, and convection theory, seafloor spreading, and theory of continental drift. Plate tectonics theory. Plate tectonics theory is the Earth's outer layer. Earth's outer layer is fragmented into plates that are in constant motion.
Expansion theory is the increase in distance between any two given gravitationally unbound parts of the observable universe with time. It is an intrinsic expansion whereby the scale of space itself changes. Continental drift theory is the hypothesis that the Earth's continents have moved over geologic time relative to each other, thus appearing to have drifted across the ocean bed.
And now, let's proceed to theory of isolasticity. So, theory of isolasticity, state of gravitational equilibrium between the Earth's lithosphere and asthenosphere. Tectonic plates float at an elevation which depends on their thickness and density.
The contraction theory. Earth is shrinking because it is cooling and the great pressure squeezes parts of the Earth into a smaller volume. Gravity draws the crust inward causing it is buckled, bent, and drenched. The convection theory. Convection within the Earth's mantle pushes the plates. Movement of a fluid caused by difference in temperature. According to his history, convection currents are set in the crust and heat comes from the disintegration of radioactive elements. As heat accumulates, rocks becomes plastic and moves upward, causing the surface of the earth to bulge.
Structural features of Earth movement. Strain and stretching of crustal rocks due to stretching caused by tensional forces which cause formation of rocks or faults. Squeezing and shortening of crustal by compressional forces rocks, which also cause formation of faults. Crustal rocks to shear by slipping past each other or by dividing into layers, which is caused by shear forces. Result of horizontal earth movement result in formation of the following features: faults, rip valleys, fold mountains, escarpments, basins, tilt blocks, block mountains. Vertical earth movements. Movement which occur along the Earth's radius or towards the Earth's surface or towards its center. Effects causes. Subsiding, sinking, downwrapping, or pulling of crustal rocks. downward, uplifting, upwarming, or pushing of crustal rocks upwards, tilting of rocks or shearing in vertical direction due to greater uplift on its side. Result of vertical earth movements. Raised cliffs, tilt blocks, rift valleys, fault escarpments, plateaus, basins.
Causes of Earth movement. First, magma movement when the Earth crust. Second, gravitational force. Third is convection currents in the mantle. And last is isostatic adjustment. Magma movement within the Earth crust. When magma moves with force pushing crustal rocks horizontally or vertically. When magma moves from reservoir and leaves empty spaces onto which crustal rocks are pulled inwards. The gravitational force is when the attractive force of the Earth pulls crystal rocks into empty spaces left after magma escaping from the reservoir. Convection currents when within mantle. When convection currents and magma in mantle drag crystal rocks with frictions, horizontal movement of current causes horizontal movement while vertical causes vertical movements. Isostatic adjustment, it is a rising of continental masses to restore the opposite states of balance between shale and semi-layers. Isostasy is the state of balance between shale and semi-layers. It can be disturbed by erosions on continents and melting of continental ice sheets. The reduced weights causes continental masses to rise.
Of fault: the normal fault, the reverse fault, and the strike-slip fault. Fault system: rocks responds to stress being squeezed or pulled apart near the Earth's surface by breaking. When rocks break and there is no offset along either side of the break is called a fracture or joint. Rocks can also break as a result of thermal expansion and construction, the effects of fluid freezing, or when rocks are squeezed together or pulled apart. When the rocks move past each other along fracture surface, it is called a faulting. Fault surfaces are often nearly planar, and that planar surface is referred to as a fault plane. There are four types of faulting: normal, reverse, strike-slip, and oblique. A normal fault is one in which the rocks above the fault plane or hanging wall move down relative to the rocks below the fault plane or foot wall. A reverse fault is one in which the hanging wall moves up relative to the foot wall. When rocks on either sides of a nearly vertical fault plane move horizontally, the movement is called strike-slip. An oblique slip fault is a special type fault that forms when movement is not exactly parallel with the fault plane. Oblique movement occurs when normal or reverse fault have some strike-slip movement, and when strike-slip faults have either some normal or reverse movement. It is not hard to recognize a fault when you look at an outcrop or an exposure. Usually different rock types or rock features such as quartz, veins, mineral layers, or beds are broken and offset along the fault plane. Faults are commonly marked by debris or breccia that forms when there is movement along the fault plane. Grinding of rock along the fault plane may also produce a clay-like pulverized rock called gouge. Sometimes, when the fault plane is exposed, you may see grooves, striations, scratches, and asymmetric fractures called lichen sides that provide visual evidence of movement.